what gets really interesting, and this is something most scientists don't even know about yet, is level 3, the deep layer of aging. There's actually a DNA clock that tells our bodies how old we are. I could take your blood and read it, and I could tell you roughly when you're going to die.
Hey everyone, hope you enjoyed this episode brought to you by our sponsors at Peak Tea. Hey everyone, welcome to Health Theory. Today's guest is Дейвид Синклер. He's an acclaimed Harvard professor who's doing some of the world's most groundbreaking work on human longevity. He was named by Time magazine as one of the most influential people on the planet, and his new book, Lifespan, The Revolutionary Science of Why We Age and Why We Don't Have to, is set to permanently shift how we think about the inevitability of aging and possibly even death. That is exactly where I want to start. So this is my favorite topic. I want to live forever. I make no bones about it. I know that right now, though, I'm on a collision course with death. So you have a really interesting theory about what makes us age that, if I'm not mistaken, you call the information theory of aging. So what exactly is the information theory of aging, and how do we take advantage of it?
So aging actually has been worked on for about 5,000 years or more. And just in the last 20 years, we've come up with a set of hallmarks of aging. There are about 8 of them. And I think many of your viewers will know that there's telomere attrition, the ends of chromosomes get shorter, mitochondria, the power packs, we run out of energy as we get older. There's a list, a long laundry list. And most of the people in my field have said, okay, we've figured out aging. We've got this list, we put it in a nice pie chart, and that's it. But what I'm saying is that why does all that stuff happen? It's not enough just to tick off what happens. You have to understand, is there an upstream cause of all of that? And so in my book and in scientific papers we are now putting out for the scientific community to read as well, what we think is going on is that our bodies are losing essential information as we get older that drives many, if not all, of those hallmarks that we know exist.
So in what way is the epigenome involved in this? How are we losing the information? Give people a quick little diatribe about the difference between genetics, which I think they get, and then the epigenome and epigenetics and how that plays out.
Yeah, for sure. It's not that complicated. There's really just 2 main types of information in our body that we get from our parents. The first is genetic. We all know about DNA and the 4 letters, A, T, C, G. It's a long molecule in the cell, and it's a string of letters. That's digital. That's like the music that's on a DVD, those things we used to use to store movies. But there's another level of information that's above that in the cells, which is the reader of the information. That's called the epigenome. And that really is different because it's analog information, in the same way that records and cassette tapes. They sucked. They were terrible at storing information. But the problem is we have an analog version of information, the epigenome, which controls which genes in the string of DNA are turned on and off. And
why are you considering that analog? I don't think I understand how it actually works. Like, I can imagine DNA sequences as just sort of repeating the ATCG code, but what is analog about the epigenome? This, reading about it in your book, is the first time that I began to imagine it in a different way.
Well, it's very clear that if you just have 4 letters, that's digital, so we understand that. But the epigenome is the structure of how the DNA is organized. So DNA isn't just flailing around like a string. It's actually packaged up around proteins we call histones. And it's like if you spool your hose in the garden, you loop it around and then you can put those loops into bigger structures. Then you get a chromosome, which you can see, any high school student can see under a microscope. That chromatin structure, as we call it, is the epigenome. And so when the hose is looped tightly and spooled up, that's stopping genes from being read. So genes are off when they're compacted, but also if the cell needs to read certain genes, and a nerve cell needs to read the nerve cell genes, and the liver cell needs to read specifically the liver cell genes. And so they open those ones up, and now the cell can get access and read those. That's an analog system because it's varying all the time. It changes when you wake up, what you eat.
So it is literally the amount that the DNA is unspooled and the place in which it is unspooled so that it can be read.
Right, and that's what determines the cell's function and identity, which when we're born, we're 26 billion cells. each one of those cells knows what it is and what it has to be 80 years later, it and its descendants. And over time, what I'm saying is aging is caused because cells lose their packaging, and then eventually cells lose their identity. Disease ensues, cells check out, they become zombie-like, and then
senescence, right?
Senescence, and then our organs fail, and we die. But until recently, we had no idea why that was happening.
And so why is it happening?
Well, so the packaging's the really important part, because much like the software runs the code, the epigenome controls which genes are on and off. And if you stress the system, and by that I mean biological stress, and the biggest stress you can cause to a cell is to break its chromosome, because it's going to die if it doesn't fix it, or worse, for the body, you get a tumor. So the cell has to hunker down, stop dividing, arrest just about everything it's doing, and then try to repair that broken DNA. But in doing so, it has to do two things. First of all, it has to take proteins from somewhere else that are doing a good job keeping the cell from functioning, or making sure the cell's functioning correctly. And those proteins are used by the cell to repair the DNA that's broken. But also what's happening at the break is that that's all opening up as well, because you remember, if you break a DNA and it's spooled up, you can't fix it, you can't glue it back together unless you unpack it, stick it back together, and then you've got to repack it. So this movement of proteins and the unpacking, repacking of the DNA, I believe, leads to cells losing that original youthful, what we call a gene expression pattern of how the genes are turned on and off. And nerve cells, as they get older, lose their ability to stay nerve cells, and liver cells lose their identity as liver cells.
All right, so do proteins, the way that you're talking about them, sound like little creatures? I think of them, because of my background, like powder, like just sort of inert molecules, which clearly, judging by the way that you're talking about them, they're not. I've seen them animated before as having like articulatable shapes, and they actually move. Is that accurate?
Well, that's essentially it. It's super exciting when you realize that proteins aren't just blobs or powders in the cell. They're actually little machines, like Pac-Man, that go around and they can change the function of other things. They can package the DNA. And what they do is they create chemical reactions that normally would take 1 billion years to happen. This is what an enzyme does. It accelerates reactions. And so we've got about 20,000 different types of enzymes in the body, and they do different things. But what we've discovered over the last 20 years is there are certain types of enzymes that help package the DNA and help with the DNA repair. These are the ones that are doing the ping pong game. And without those, we're screwed. We basically will age more rapidly. Conversely, what's really exciting is we've discovered that you can make them more active to make sure the DNA is packaged correctly and the repair is very efficient. And there are ways you can do that: exercise, dieting, being hungry. They allow these enzymes that control our body and make us healthier. They make those enzymes much more active. So instead of a Pac-Man doing this, you exercise, you diet, take a molecule that we work on, and it'll go around and fix everything much more efficiently and keep you younger for longer, we think.
Why do you use the Pac-Man analogy, which makes me think of it's eating something? Is that what's happening? Is it eating cells that have a level of senescence, or is it more Bob the Builder, and it's going around tearing some things apart, putting some things back together?
Yeah, it's more like Bob the Builder, but I think a good example for at least the enzymes that we work on, called sirtuins, that protect the body, they're like a little tiny pair of scissors. They clip off chemicals called acetyls. And in doing so, when they clip off the acetyls off those packaging proteins, the DNA gets more compact. And that's called gene silencing. And over time, as we get older and through this DNA damage process, the sirtuins get inactive, they're distracted by DNA repair, and the packaging of that DNA, that hose spooling, starts to loosen. And now genes that have no business being on in the brain come on, and partly I believe that's why we have these diseases of the brain.
Fuck, that's so interesting. Okay, so one, I want to know from a lifestyle perspective, what are we doing that's speeding that up? And then two, what can we do from a lifestyle perspective to begin slowing that down or reversing it?
Well, so I've been studying these enzymes, the sirtuins. We have 7 in our bodies. I've been studying them for about 25 years. And what we've learned is that they respond to the cellular environment. There's a chemical that they require for gas. Think of them as the fuel, called NAD. And there's another molecule that is like the accelerator on the enzymes that makes them go even faster, and that's one of them is called resveratrol, which we discovered years ago from red wine. And together they actually do really great things on these enzymes and make them keep the body younger at least. For 25 years we've been studying mostly animals and even little fungi, yeast cells. And what we've learned from those studies is that these are largely involved in responding to when organisms are under threat of survival. So how do you make the body feel like it's under threat? Adversity. So one is run a lot, or at least become out of breath. A few times a week, your body will say, "Oh man, we had to outpace one of those saber-toothed cats again. Got to build up the body." The other is to be hungry, either a couple of times a week or every day. Skip a meal or two, and then your body will turn on these sirtuins, make more of that fuel, NAD, for the enzymes, and we think that's what's in part responsible for the health benefits of those lifestyle choices.
All right, one thing though that you talk about that I found really interesting is this notion of what may be good for you when you're young may come back to bite you in the ass when you're older.
Yeah.
So it's like the whole notion of Hормezis, that a little bit of bad is actually extraordinarily good, which is exactly what you're describing now. Get out of breath, do all this stuff. And so when the information started pouring out that the only thing across every known living organism that extends lifespan is to eat less, which you talk about in your own book, it feels like you're saying to do it for that reason. Just don't put as much stress on the system. But now I hear you saying, no, what you actually want to do is stress the system. Won't that stress of, I just ran from a lion, fuck, I'm starving, won't that begin to stack up and become problematic?
Well, actually, if you step on a snail, it's going to die. So there's certain amounts of stress that you don't want to do. But what you want to do is get the body to fear adversity and the future, but not enough to cause lasting damage or the unspooling of the DNA that'll lead to disease and eventually death. So you don't want to overdo it. You want to be a little bit puffed, you want to be a little bit hungry, but of course starvation, malnutrition is not going to make you live longer. So it's a fine line, and what we've learned from many animal studies and increasing numbers of clinical trials in humans is that you want to pulse it, let the body recover, not constant. We used to make animals go hungry all their lives, and it worked. But it actually works better if you let them recover, and I think that's the secret.
Then let's really dive into that. So I'm guessing you're talking about where animals were denied something like 20 to 30% of their caloric intake for very long periods of time. It was extending their life by what, like 30% or something? So super interesting. But you're saying that if their caloric intake over a long period of time is roughly the same as an animal that's just allowed to eat until it's satiated, that if it's done in a pulse pattern of hunger, and almost overfeed, they actually have the same benefits as the animal that has a chronic deficit of calories?
All right, well, let's be clear. Nobody knows what the perfect diet is, even when it comes to fasting. It's all largely based on rodent studies. So what I can tell you about the rodent studies, which I'm very familiar with, is that if you take a rodent and reduce its calories by 25% for its whole life, it will live longer, 30%, but it'll be really miserable and aggressive. And that's true for us as well. I've tried calorie restriction for about a week and I gave up. I was pretty angry. But what we discovered, my colleagues discovered, is that it's not just what you eat, it's when you eat that's important. And what's been found is that as long as you have that period of hunger in a mouse, so you can feed them every other day, then they can gorge themselves as much as they want. And they do. They eat about 90% of what a mouse having free access to food would eat. But they have the same longevity benefit as a mouse that's always been hungry. And if that's true, what that means is for us is that we can enjoy life as long as we have that period of hunger once a day or maybe twice a week. And I believe the only reason we age, we could live for 1,000 years otherwise. The only reason we age is that our repair systems become complacent. You mentioned that what is beneficial for you when you're young come back to bite you when you're old. What we think is that these repair systems are very good when we're young. So the idea is, it's called antagonistic pleiotropy, and I think it's right, and that is that we evolve to stay healthy and alive and fit till we're 40, and then the forces of natural selection decline after that because we've essentially bred, we've often had children, but we don't need to stick around beyond that, and building a body that will last 1,000 years is pointless at that. So most species only live as long as they need to reproduce, and then a little bit more. If you're a mouse that could die within 2 years. They only build a body that lasts 2 years. If you're a whale that has no predators, you can live for a couple of hundred years. That makes more sense.
Why does the whale live for a couple hundred years? Like, I would say it's pretty safe to say certainly at some point in our past we became a pretty clear apex predator. It's not that things couldn't take us out, but I mean, by and large, obviously look at how far we've come. They didn't. So why would we only live to 40? Is it that whales continue to breed and be useful in that sense?
So that's really super interesting, and very few people talk about this. The reason is that we were not at the apex of the food chain until recently. But in a world where we typically would die from starvation or from war, a lot of men didn't make it to 40 because of that. We were at the middle of the food chain. Only now we barely have a chance of dying before 70 or 80 unless we're unlucky. Give us another 5 million years of evolution, we could evolve 200-year lifespans. That's what should happen if evolution continues. A whale has been at the apex for about 30 million years, and they've been allowed to evolve those long lifespans. We are just like them. We share most of their genes. They're warm-blooded, they produce milk, they're conscious, they're basically us in the sea. So anyone who says we've reached our maximum limit doesn't know what they're talking about.
Talk to me about this notion of resetting the biological clock. How do we do that? What's the mechanism? And so obviously going hungry occasionally, exercise is going to help, but I know that you have a regimen that I'll lovingly call a regimen of drugs or precursors to things that we can take. What can we do to reset that biological clock?
Well, there are different levels to resetting aging. There are 3 levels that we know of. The first is pretty easy to reset or to manipulate. These are the proteins that turn genes on and off very quickly. We call them transcription factors. And they basically read a gene and make a protein. That's what they do. That's level 1. That's easy. Go a little bit hungry, that'll change. Level 2 is a little bit harder. The level 2 is not just changing which genes are quickly turned on and off, but actually silencing genes for a long time. And this is where my enzymes that we work on, the sirtuins, come into play. Let's go back to the Pac-Man. They clip off acetyls off these packing proteins. You spool up the hose, and it becomes locked in. That gene gets silenced for a long time. So to do that, you can exercise, you can diet, but you also, I think, you need a little bit of help as well. What gets really interesting, and this is something most scientists don't even know about yet, is level 3, the deep layer of aging. There's actually a DNA clock that tells our bodies how old we are. I could take your blood and read it, and I could tell you roughly when you're going to die.
What?
Yeah, we can do that.
What are you looking for?
We're looking for chemical groups that get added and subtracted to our DNA, the long string in the cell. You get chemical modifications in predictable ways as you get older, starting from conception. So even in the womb, even as a kid, even as a teenager, you're aging based on this clock that goes up linearly. And where you fit on that line is very accurate. That tells you your biological age.
But how do you know when the person's going to die? Is that just based on
draw a
actuarial
straight line.
tables? Is it actuarial tables though? The average human lifespan is 86, and is that what you mean? Or could you see something specific in my line that would say, ooh, you're headed for 68, sorry.
No, it's not specific, but what it's based on is machine learning based on thousands of people's code of methylation on the genome and comparing that to their health and their date of death.
Oh, fuck, that's so interesting. So if you were to take my blood right now, what would you look for exactly?
We would read the methylation. These are chemicals, hydrogen and oxygen, bound to the DNA, chemically, physically bound. And those accumulate as you get older in very predictable ways. In fact, they're so predictable that we can use the same clock to measure a dog's age and a human's age.
Whoa. All based on methylation.
Right.
Okay, what causes methylation?
Well, there are 2 classes of enzymes, the ones that add the methyl chemicals and those that subtract it.
Okay. How do I take a boatload of ones that subtract it?
That's what we're working on. Now, here's the key. Level 2 aging reset, which we can do by some of the things that I'm doing in my life, and probably you are too, those aren't permanent changes. You can't just do that and expect that take one treatment and you go on living for another 10 years.
Okay.
Because level 2 isn't as permanent. It's somewhat permanent than level 1, but level 3 is truly permanent. you could reset yourself 10 years and then go back and then wait another 10 years and potentially reset the clock again if you know how to do that. And we're just starting to figure out how to do that.
Okay. So level 1, diet, exercise. Cool, got it. Level 2, metformin. You taking metformin?
Right.
Okay, so I've talked about this on the show before, but explain what is metformin, why is it prescribed to diabetics, and now why is a seemingly rash of non-diabetic people taking it?
Yeah, so there are 3 main pathways that regulate aging in animals and probably in ourselves. There are the sirtuins that I've talked about a lot today. There's one called mTOR, which responds to how much amino acids how many amino acids are in your body. It will hunker down and protect the body the fewer amino acids it has access to.
Okay.
Okay. Then the third is called AMPK, and this is the energy sensor. When your body has low levels of energy, it will allow the body to hunker down and protect itself from diseases. But why AMPK is worth mentioning is this is one of the targets, as we call it, of the drug metformin. Metformin will activate this AMPK pathway and make the body think that it's hungry when often it's not, and also keep your blood sugar levels more steady.
Why would I, hungry at a cellular level, or I actually experience hunger?
At a cellular level.
Okay.
But it also has an interesting side effect is, for a lot of people, myself included, it's a bit harsh on the stomach, so it also reduces my appetite. But what's great about metformin is that it's been in millions of people for a few decades. So we know the side effects. They're relatively
and
low.
Sorry, really fast. So metformin is creating at a cellular level the sense that I'm hungry, and you're saying that from a hormesis perspective of a little bit of bad, it's like stressing the system, and that's why we think it works?
It is. It's exactly doing that. And so that it actually helps the body respond in a way to boost the energy supply. So one thing it does that's undeniable is it boosts the numbers of mitochondria.
It actually creates additional mitochondria. So your cells are getting more efficient or more able to generate energy?
Right, over the long run. But in the short run, what it does is it actually poisons part of the mitochondria. So it's a little bit of poison that leads to benefits down the line.
What part is poisoned?
It's called complex 1. So that there are protons that are in one part of the area of the mitochondria, in a membrane region, and the cell builds up protons. It becomes really acidic in that region, but the cell wants to release them. So what they do is they put little pores in between the membranes so that they can leak from the high concentrated zone to the low concentration in the middle. And as they pass through that pore, it spins the pore around, and that spinning, physical spinning of that protein will generate chemical energy called ATP.
That's how ATP is created.
And without ATP, we're dead in about 10 seconds.
Yeah. Okay. That's crazy interesting. And you're saying, sorry, to go back to the poison is elevating those levels, which is causing more to go through the pores?
It's actually decreasing ATP in the short run. So the cell says, man, I haven't got enough chemical energy in ATP.
So that's what forces it to create more mitochondria.
Right.
So that's the poisoning part.
It is.
So the increased number of mitochondria is in response to the slight poisoning.
Exactly. But there are 2 other important points. The cells in our body also think that they need to become more sensitive to insulin.
Yeah.
Which keeps our glucose and sugar levels more steady.
Okay.
Yeah, that's key because that's what helps the type 2 diabetics recover and prevents the disease from getting worse.
Yes.
And the second is that it's just been discovered in humans that if you take metformin, a lot of it, and exercise, it can blunt the effects of exercise on building mitochondria. What we think is going on is that you don't want to always have metformin in your system, or your body won't have a chance to recover from that slight poison. I'm not going to prescribe anything, I'm not a doctor, but we think it's better to take metformin on days that you're not exercising and recovering, and pulse it again. So you got metformin, exercise.
Right. I know you're not prescribing anything, but how many days are you taking it? How many days are you not? How often are you exercising? How often are you not?
I actually spent a lot of my 30s and 40s not exercising at all. It's crazy, right? Someone like me. But I've become better at it now that I was approaching 50, now I'm 50. So I spend about 4 hours in the gym on the weekend with my son, Benjamin.
Do like 2 hours a day?
No, 4 hours straight, but it's not all exercise.
Okay.
So it's an hour with my trainer, Sean, who does mostly a combination of weights and stretching, some free weights, some machines. Then it's another hour on my own with my son. We do some treadmill, some more stretching, and essentially just muck around doing stuff that's fun for him. And then we do some yoga downstairs in the gym, a little bit of relaxation. But the best fun part that I really love is at the end, we do a sauna, hot tub, cold bath, sauna, hot tub, cold bath for about an hour. Jesus. And I feel fantastic after that.
Talk to me about that. So in your book, you go into cold exposure. You said you moved to Boston, it sucked coming from Australia, and you bundled up, and now you wish you hadn't. Why cold exposure? Is cold and hot both necessary? What's the difference?
Well, there are a few reasons. One is the high-level view is that anything that stresses your body, puts it into a state of shock, is good in the long run. But a little bit of perceived adversity, being a little bit too hot, a little bit too cold, and especially the gradient between those two, which is why we jump from one to the other. The next point is that I've looked at the literature. And at first, when I was prompted by my publisher to look into this scientifically, they said, what about this cryotherapy? What do you think? And a couple of years ago, I had no idea that this was real. It sounded like bullshit to me. But I looked into it, and there are two important things. One is cryotherapy or cold exposure will build up what's called brown fat. We didn't know brown fat existed in humans until about 5 years ago. Typically, it's across your back and in other regions. You can see it with a PET scan, but otherwise it's pretty invisible. It just looks like fat. But brown fat's particularly healthy because it has a lot of mitochondria, and we think it also secretes little proteins that tell the rest of the body to be healthy.
In what way to be healthy?
We're not sure yet.
That's interesting. Oh man, I want the answer to that question.
But it certainly revs up your metabolism and will burn energy. If you're looking to stay lean, having a bit of brown fat is all good. So my friend Ray Cronus and I have written on this, and Andrew Bremer at the NIH. We call it the metabolic winter hypothesis. And essentially it's saying that in our lifestyles these days, we're always warm. I'm wearing this jacket. We sleep with the covers on. We turn up the heat. We never get exposed to cold unless we force ourselves to. And we think that that's possibly largely responsible, if not, maybe partly, perhaps largely responsible for the diabetic problem we have.
What?
Okay, so if you're cold at night, you're going to burn a lot more energy staying warm.
Yes.
Turn on your brown fat. Now that's going to keep people lean. If we bundle up and we eat the kind of diets that we see in the supermarket, that's going to be doubly bad for our bodies.
Yeah.
We're warm, we're not losing energy, and we're eating a lot more.
Yeah, this stuff is so interesting. Okay, so what's your advice? Whatever you're about to tell me, no, I'm going to do it. So, how frequently do I want to be doing it? Is it every day? What's that look like?
Well, what I do is, because I'm busy and I don't have a sauna or a cold tub at home, I subject myself to this stuff for about an hour on Sundays. And what I do is I spend about 15 minutes at 150 degrees Fahrenheit.
Wow.
That's reasonably intense, but you get used to it. Then we go into the steam room. We're sitting there chatting. It's great. Temperature's lower in the steam room because humidity is saturated. The roof's dripping on you, hot water.
Right.
But I don't know if the steam helps, but I certainly love the feeling of being in there, and my skin starts to be healthier because of course it's cleaning itself out. And then the final thing I do is hot tub, pretty hot water, and then I go and dunk below the water a couple of times in water that's less than 4 degrees Celsius. So that's so cold that it takes your breath away.
Yeah.
Yeah. But it's great.
Interesting. Was there anything else on level 3 that we should know about?
Yes. So work that we've done recently, just in the last year, is finding ways to tweak the cells and the tissues of mice, at least, to reset the clock. We've been working for 10 years, as I said, accelerating the clock. We can drive that hand of the clock forwards now. We cut the DNA of the animal, let it heal, and in doing so, we distract those proteins from where they come from. So we're disturbing this survival circuit so much that we disrupt the spooling of the DNA. And what we got was an old mouse, by every account, based on histology, which is looking at the tissues, based on their physiology. They got gray, they got arthritis, they got heart disease even. And when we look at the molecular clock, that methylation clock, they were 50% older
I mean,
compared to
they had more like clumps everywhere.
those methyl groups were added.
To the DNA? Yes?
Right, right.
Okay.
So we had given them heart disease and Alzheimer's or dementia, we'd given them all these diseases, but by measuring the clock, what we had actually done is give them aging. But that was the first step. That took 10 years. The last year, we've been asking, how do you get the hands to go backwards? That's a lot harder. But we were fortunate that the 2012 Nobel Prize was won for the ability to reverse that clock in cells. It's called, it was the prize awarded to Shinya Yamanaka, a Japanese fellow, very smart guy, and he found at least 4 genes that when you put into, say, skin cells of an adult, if you gave me your skin cells, I could go back to the lab and basically clone you. I could take your cells, make a stem cell pool, and I could grow you into a new little liver or a new little kidney. That's all easy. Not easy, but it's doable.
Wow.
It's doable. What that tells us is that those 4 Yamanaka genes can reset age. If I can take someone who's in, like you, who's in their early 40s and make a new you, as we've done now for many species, dogs, cats, sheep, monkeys, those animals, we can reset the clock 100%, and those animals actually live a normal lifespan. That tells us that the instructions to be young are still in the cell somewhere, as though there's a backup hard drive that tells the epigenome, those spools, how to go back to be young again and get those methyl groups back to being young again. Not up here, but back there. But don't strip them off too far to be a stem cell, or I'll basically turn you into the world's giant tumor.
Yeah. Okay, so one, why do I become a tumor? Because a tumor is a cell that doesn't know to stop.
Right.
So what is it that you're breaking in that process that makes it so dysfunctional?
Yeah. So in terms of the clock, let's just start with that. Shinya Yamanaka wound the clock so far back it went back to 0, back to midnight. That we do not want to do because the cells lose their identity, and that's the last thing we want to do. We don't want to go back to
because it's
original.
dangerous to have a pluripotent stem cell in the wrong place in the body?
Of course, it'll grow. It won't stop growing.
But why does it become a tumor? Why doesn't it become a liver or a lung? Like, I would get the problem of having a liver develop in my brain, but I'm just saying, like, why does it become a tumor cell instead of an actual functioning liver?
Well, so when you go back far enough and it loses its identity, it will just multiply into a mass without cellular identity.
So there's something else going on that stops it from figuring itself out.
Right. So in the lab, if we take a pluripotent stem cell and we want to make a liver cell or a neuron, a nerve cell, we give it a bunch of chemical signals in what we call the niche. And when one of these cells lands in a niche around those old cells, they'll use that stem cell to rebuild tissue. But imagine if we could reset the clock, not all the way back to a stem cell, but just partial reset the clock so that you could go back to being 20 again.
Right.
That's what we're able to do in some tissues in the mouse right now.
How do you do it en masse? When it's cell by cell, DNA strand by DNA strand, like how the hell do you get this to take effect through a whole joint, let alone the whole body?
Yeah. Right now the way we do it is we inject a virus called an AAV, and this virus will target certain tissues and deliver the genes to most of the cells in that tissue. For example, we are treating aging of the eye in mice. So we can take an old mouse, we deliver a virus, the AAV, into the eye. It's a tiny little prick. It's the same virus that's used to correct genetic deficiencies in the eye right now, FDA-approved drugs. So this isn't science fiction. This is out there in the world right now. We give it to the old mice. We give them an antibiotic called doxycycline. Okay, same thing you might take if you got Lyme disease. And that turns on these reprogramming factors. We don't use all 4 of the factors, O, S, K, M they're called, because one of them causes cancer, the M. We leave off the M, we put O, S, and K into the eye, turn it on, leave it for a few weeks, measure what happens to the eye, and those mice can see again like they were young. So we've tested 3 different types of damage to the eye. The first one we did was a Hail Mary. So a lab near ours, across the road, works on rejuvenating the spine and the optic nerve.
Which is crazy.
Yeah, because we know as soon as you're a couple of months old, you're not going to regrow a spine. It's one of the first parts of the body that ages, in fact. But jellyfish can regrow, axolotls can regrow an arm. We lose that ability when we're very, very young. So the question was, if we turn the clock back a lot with our OSK genes, will those nerve cells be young enough to regrow back to the brain if we damage them? And that was the experiment. They pinched the back of the optic nerve so that the nerves were defective, and they started to die back towards the brain. Of course, the mice lost their vision. We then turned on our reprogramming factors. We now see that the nerves get young again, wind the clock back, and they regrow back to the brain. We could give ourselves the healing ability that we only had when we were embryos. And you start to think about, what could this lead to? If we can do this safely, of course safe is the important word, across the body. Imagine one day you could have every cell in your body able to be rejuvenated like that. You cut yourself, you break a bone, you lose your mind, you have a dementia. You take a course of doxycycline for a few weeks and then stop, switch it off again, and you heal. If you turn it on at high levels, there's a lab in Spain that has shown that you can get small tumors in some animals in the kidney. So we've been very careful to not just blast the cell with these factors permanently. We've titrated, or what we say, brought the levels down to very low levels and switch it off when we don't need it. But we have given mice this virus throughout their body. We inject it into a vein and we turn it on. We've left it on now, expecting the mice to die. A year later, they're perfectly fine.
Wow.
So it appears to be safe, but of course there's a lot more work to do. I'm a scientist and I'm developing drugs. I have to be very aware of the dangers.
Sure.
Please, nobody go out and try this at home at all until we know more. But the eye is a good testing zone because it's protected, and if there's a problem, it's shielded from the rest of the body. It won't go too far. But everything we know now is that it seems to be very safe, at least in the eye.
Wow, this is crazy. So that is there an element of getting better, improvement, human performance, or anything that you can tease us with?
Well, we've actually published results that in mice, if you give them an NAD booster molecule that will turn on these Pac-Man enzymes called Sirtuins, those mice, when they're old, can now run 50% further. In fact, some of our old mice ran so far that the treadmill stopped because mice are not supposed to run more than 3 kilometers.
We haven't talked about NAD yet. Tell me what NAD is, what are the precursors, how do I supplement for it?
So there are a few on the market. I don't endorse or sell anything, just by the way. Even if you see me online, that's not me. So that said, there's one called NR, which stands for nicotinamide riboside, which is a very early precursor to making NAD in the body. There's an intermediate from that called NMN, not to be confused with M&Ms. Please don't do that. That's not healthy. And then the cell turns NMN into NAD. And you can take all three actually, or each one of those three, and raise NAD levels in animals. And now we're doing, myself and many others are doing human studies, and we've seen that NR, and in my case NMN, does raise the NAD levels of older people and young people alike up to levels that we think you could rarely achieve even with being a marathon runner.
That's crazy. So just to bring this home for people, talk to me about your dad and his N of 1 experimentation with NMN.
Yeah. So my father has been on the same regimen as me, resveratrol for over a decade, the red wine molecule. He's been on metformin longer than me because he was a borderline diabetic, type 2 diabetic, and he's also on NMN now. And he seems to be doing great. He's now 80. When he was in his 70s, he was slowing down. He was starting to say the same things twice, typical 70-year-old. He's doing great now. He's 80. He's got a new lease on life. He started a new career down in Sydney. He's hiking the world. Right now, he's traveling around America, driving his elderly friend around. Wow. His friend, unfortunately, ended up going to the hospital the last few days. So my father is taking care of his friends who he's seeing on the decline, and he's, if anything, improving every year.
I'd love to hear more about resveratrol, which is something that I've completely written off until I started researching you. It seemed for a red hot minute like it was real, and then it seemed to completely die. And I know that you got sort of caught in the middle of some of this stuff. So where has all forget like what pop culture thinks of it, like what's the reality of it?
Yeah, so resveratrol was a proof of concept molecule back in 2003. The first of its kind that could mimic caloric restriction, make mice healthy on a high-fat Western diet. And it was a great proof of something that we were trying to figure out. And it led to drugs that went into humans that looked really promising. I got embroiled in a scientific and a corporate war. So in the case of Pfizer, they put out a scientific paper that said essentially everything that David has said is wrong. Okay, and then that was a great headline. Harvard scientists started companies is wrong. Okay, and then I spent about a week in bed saying, fuck the world. Why am I doing this? Why am I working so hard for society if they don't care? But I worked my way out of bed. I thought, let's dig deep and see if they're right or if we're right. And so for another 3 years, we really worked hard in my lab at Harvard to test whether we were right. So the question was, with this Pac-Man that spools the DNA, does resveratrol work on it, or is it working on something else? And that, to scientists, is really important. Because if it's not working on this, all the drugs that we're trying to work on this are probably working the wrong way that we thought. To cut a long story short, what we found and published in the journal Science, which is one of the top you can do, and I say that because it's validated science, is that we showed that resveratrol does bind to the Pac-Man, and it is responsible for this. And we now have new information that we haven't published, but I'll tell your audience about it. We've made a mouse that is resistant to activation of the Pac-Man. We can tweak the enzyme just in one amino acid in that protein out of about 1,000 that blocks this movement activation. It's normally chewing like this, but if we add resveratrol to a normal mouse, it'll do that. To our mutant mouse, it's this.
And which is better?
What do
The
you mean?
rapid munching?
Rapid munching's better.
Okay.
Because the rapid we think was responsible for the health benefits and the longevity
So
effects.
what you're showing is by slowing it down, you cause real problems, and thusly, if you have resveratrol in there and get it munching really fast, that you've done something positive.
Right, and our mutant mouse should be resistant to the benefits of resveratrol if we're right. But if Pfizer is right, then resveratrol should still provide benefits even though this enzyme
Because
is
it's
blocked.
working on some
other way.
Got it.
So the mouse that could not be sped up, the mutant mouse, does not live longer when given resveratrol on its high-fat diet.
Interesting.
So that will be the punctuation mark, the FU, we were right. But interestingly, the world has moved on, right? Well, I'm left to clean up the pieces.
Right. Yeah, so, and when you say the world has moved on, you're talking about people like me who just assumed that it was garbage and that it's not real. And
Right.
Okay, so you've said that the only supplement you take is vitamin D. So how are you getting resveratrol in the system? Is it a drug? Do you have to have it prescribed?
Well, I'm taking resveratrol. I have...
And would we call that a supplement?
Sure.
And it's commercially available?
It is, if it's a legitimate seller and it's 98+% pure. It seems to be similar to what I take.
And ballpark, how much do you take?
I take a teaspoon into my yogurt. That's probably close to a gram.
Every day?
Every day, yeah.
Okay. Resveratrol, roughly a gram. Are you taking NMN or is that just your dad?
Both of us.
Okay, and then metformin?
Right.
Those three, anything else?
Those are the main things that I think are helpful. And I've been monitoring my blood biochemistry, so
And you said you took an MRI of your heart.
Right.
Which I love.
Well,
what are things that we should be testing? Assume for a second I'm willing to go all the way, do any crazy test to know if what I'm doing is working. What would you recommend?
Well, I avoid X-rays and CT scans unless I have to.
Sure.
Right. If your doctor says go for it, please don't refuse that. But otherwise, don't do it for fun. Don't do it because you're curious. Because those CT scans will break your DNA, and when we break the mouse's DNA, its age goes up by 50%. So,
whoa!
Right. So avoid DNA breaks as much as possible. What I do is I take a blood test from a company called Inside Tracker, which, in full disclosure, I invested in years ago, and they look at about 30 parameters in your blood and give you feedback. It's doctor supervised, so it's legit, and it's based on a lot of science. And that at least gives you some feedback about your body, about what's actually happening if you change your lifestyle or you take a supplement, or even a new drug for that matter. So you've got to be monitoring, because you don't want to fly blind. You don't know if for you you're doing harm or doing good. So do a blood test. At least go to your doctor and have a blood test for goodness sake. You could have your genome sequenced, or do something that looks at the variants in your genome for relatively little cost. I think it's $99 now. I gave a test of that kind to my whole family as a Christmas present. And what we've learned is that some of our family members have variants that predict longevity. some don't. Some have mutations in their genome that are a little bit scary. Down the line, you could get your DNA methylation age determined, the true, what's called the Horvath clock. Some people measure their telomere lengths.
Do you have to do a biopsy to do that, or can you do it from blood?
Blood test is fine. Yeah.
So interesting. All right, where can people learn more about you?
Well, so the main site is lifespanbook.com. That's where you can sign up for the newsletter and buy a copy of the book if you're interested.
Oh, I highly encourage it.
Oh, thanks. I'm also now on social media. So I have a Twitter account. I try to talk about the science, about new findings, about things that I've just learned, and stuff like this that they might want to tune into. So my Twitter account is David A. Sinclair, and I have Instagram where I send out some little fun to-dos and not to-dos kind of thing, and that's David Sinclair, PhD.
Okay. What's the impact that you want to have on the world?
Well, that's easy. Since I was 4 years old, I've wanted to figure out why we die so fast. And in my view, I think it's cruel to have a sentient being that knows it's going to die in such a short time frame. 80 years is nothing. It goes by in a blink of an eye. Even 1,000 years will go by in a blink. It's only 20 times what I've lived. So I want to be able to leave a mark on the planet. I'm hoping to have moved the needle somewhat on the course of human history. I think we've come further than I thought we would in my whole lifetime. And I've still got a few years left to try and make what I'm talking about come true.
I certainly hope so. If you were going to have people make one change that would have the biggest impact on their health, what change would you have them make?
Well, so having read tens of thousands of papers and done this for now 30 years and talked to people, and I know what's on the cutting edge, the simplest thing you can do that would have the biggest bang for the buck is be a little bit hungry. Don't eat. But that's not to say be malnourished. Don't starve yourself, right? There are a lot of teenage girls particularly who don't eat enough. So I'm not saying that at all. You've got to have a minimum nutrition. But for those of us, myself included, who likes to eat, those of us who don't mind a bit of dessert, try to skip a meal. I skip breakfast besides that bit of yogurt. Often I'm too busy to eat a lunch. At dinner, I eat a normal meal. I don't gorge myself because that'll trigger all these defensive pathways that'll rebuild the body, or at least keep it pristine, until we have such things as the level 3 reversal, which we're now working on.
That's amazing. David, thank you so much for being here.
Pleasure.
Incredible, man. Guys, read the book, dive in. If you're like me and you want to live forever, I'm telling you, this guy is at the tip of a very exciting spear, so check him out. If you haven't already, be sure to subscribe. And until next time, my friends, be legendary. Take care. My man, that was fucking awesome. Thank you so much for that. Hey, everyone. You all know how much what you eat and drink matters. Literally, what you consume affects you on a cellular level and dramatically influences your overall health. Tea has been shown to naturally boost energy levels and provide immune system and gut health support. And given what Lisa has been through, I can tell you firsthand that focusing on your gut health is critical. Tea can also contribute to mental performance and may even help with longevity. You had me at hello with mental performance and longevity. Peak Tea makes some of the most convenient, easy to use, healthy teas on the market. Peak Teas are made from organic, high-quality leaves and ingredients from around the world, and Peak Teas deliver 12 times more antioxidants than any other tea. Peak Teas are also triple toxin screened for heavy metals, pesticides, and toxic molds. And my team here swears by Peak Tea. They love this stuff. The guy behind the camera is literally fist pumping right now because he drinks so much of this stuff. Peak Tea packets are super convenient. They dissolve in hot or cold water and are perfect for traveling or the office, or when you just have to grab something on the go. And right now, you can get 17% off their teas plus free shipping by going to peaktea.life/impact. Again, that's peaktea.life/impact. And peak is spelled P-I-Q-U-E. Go there now to get this special discount and check out the description below, or just click the link and get your Peak Tea today. Check it out, guys. Enjoy and be legendary. Take care. Thank you guys so much for watching and being a part of this community. If you haven't already, be sure to subscribe. You're going to get weekly videos on building a growth mindset, cultivating grit, and unlocking your full potential.